Hi everyone, myself Konda Krishnudu, Assistant Professor of Physics, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. In the previous class, we discussed about semiconductor devices, particularly basics about semiconductors we discussed. What is semiconductor, types of semiconductors, into intrinsic and extrinsic, particularly in extrinsic, again p-type and n-type semiconductors, how p-n junction formation takes place. All these basics we discussed in the previous class. Today in this session I am going to explain about one of the important semiconductor optoelectronic device. So first of all, the term optoelectronic or optoelectronic devices. So what are optoelectronic devices? Optoelectronic devices are the devices which are able to convert optical energy into electrical energy or electrical energy into optical energy. So many optoelectronic devices are there. Among them, one of the most important optoelectronic devices is LED. Particularly in this session, I am going to talk about introduction, construction, working principle, voltage current characteristics, advantages and disadvantages, and finally applications of LED. Now, coming to the introduction, LED. So what is LED stands for? LED stands for light emitting diode. Light emitting diode is nothing but it is a semiconductor p-n junction diode which works under forward bias. LED emits light under forward bias. Particularly, direct band gap semiconductors are used to make LEDs. Direct band gap semiconductors are produced by combining second and sixth group elements or third and fifth group elements. Coming to the symbol, so in this particular slide, you are going to observe this symbol. This is symbol for LED. This is symbol for LED. So vertical line represents the cathode, whereas the arrow shaped terminal represents the anode. Two outward arrows represents the light coming out from LED. To the left side of this symbol, you are observing a real LED picture where it is having two legs. One is small leg, another one is big leg. Small leg is called cathode, big leg is called anode. On the right side of this, you are observing LED with resistor and voltage source. So this is the picture which represents LED circuit. LED in a circuit always is accompanied with resistor. Now coming to the construction. Simple construction of LED is shown in this particular diagram. In this diagram, so many layers are there. Particularly, this is the LED which is made of using one of the direct band gap semiconductor, that is called gallium phosphide. Gallium is a third group element, phosphorus is a fifth group element. By combining this gallium and phosphorus, gallium phosphide combined semiconductor is produced. This compound semiconductor, when it is doped with n-type material, it will become n-type substrate. This is n-type substrate on which p-type gallium phosphide is grown. Between p-type and n-type gallium phosphide, one p-n junction is there. This is p-n junction. At this junction only, recombination of electrons and holes takes place. Due to recombination of electrons and holes, emission of energy takes place. Particularly in this case, emission of energy takes place in the form of light. So when electron and hole recombines at the junction, emission of energy takes place in the form of photons. Energy of photon is given by E is equal to h nu, right? So this energy which is produced in the form of light should come out. So from which side it will come out? It will come out from the top layer. For this reason, the top layer is kept empty here. The top layer, most of the top layer is kept empty. From that empty side only the light will come out. So to avoid the absorption of light which is produced at the p-n junction, reflecting coating is done at the bottom of the substrate. Also, metal contacts are provided both at the top as well as bottom to connect LEDs in the circuit. So this is about the simple structure of LED. Now, coming to the same thing, construction. So to avoid the loss of light when it is coming from LED, then the light which is produced should strike the glass air interface below critical angle. Particularly in this case, we are using gallium phosphide direct band gap semiconductor. So for this gallium phosphide, the critical angle is 17 degrees. Means the light which is produced in the PN junction should strike or incident the glass air interface below 17 degrees. Then only it will come out. If its angle is more than 17 degrees, the light will lose due to reflection. So to avoid that loss, what we have to do? To avoid that loss, we need to put this entire setup, that PN junction structure, it is kept encapsulated in a junction transparent plastic medium of high refractive index. So this transparent plastic medium of high refractive index is molded into approximately hemispherical shape. So it is molded into hemispherical shape or domed shape. Because of this hemispherical shape or domed shape, the light which is produced at the PN junction will incident at an angle less than 17 degrees, that is less than critical angle. Due to that, most of the light will come out from the LED. So enlarged view of the same structure is shown here. N-type substrate is there, upon which the P-type substrate, and the layer is molded in the form of domed shape. The light is coming from LED successfully without any absorption. Now, working principle. So LED works on the principle of electroluminescence. The principle behind the emission of light from LED is electroluminescence. Now, what is electroluminescence? This we can understood using this particular diagram. Particularly in the beginning, I told LED is nothing but a semiconductor PN junction diode. So that it is having P layer as well as N layer. In the case of P layer, there is more number of holes, positive charge carriers. In the case of N type, there will be more number of electrons. Majority charge carriers in N type are electrons. In P type, majority charge carriers are holes. As I told earlier, LED is always connected in forward bias. Forward bias. What is forward bias? When we connect P type of diode to positive battery, N type of diode to negative battery, then this PN junction diode is said to be connected under forward bias. What happens under forward bias? Under forward bias, majority charge carriers in P region will be repelled by positive battery, and hence they will move toward the junction. At the same time, majority charge carriers in N type or electrons, which are negatively charged carriers, will be repelled by negative terminal of the battery. So because of that, majority charge carriers from both regions will travel toward the junction. Due to this, thickness of the junction decreases, as well as the height of the potential barrier decreases. Because of that, recombination of electrons and holes takes place at the junction. When one electron recombines with a hole, one photon will release. Like that, many number of electrons and holes will recombine at the junction, and as a result of that, many number of photons will release. Collection of all these photons is called radiation. So radiation coming out from LED have some energy. The energy emitted by LED is given by this equation. We know E equal to h nu, or in terms of lambda we can write it as hc by lambda, where lambda is the light wavelength of light emitting from LED. So wavelength of light emitting from LED is given by this equation. Lambda is equal to hc by Ez, where h is Planck's constant, c is velocity of light, both are constants. Then finally we can say that wavelength of light emitting from LED depends upon the energy gap of the material which you are using to make LED. Energy gap of the material will decide the amount of light wavelength that is coming out from it. Particularly when we use or when we make LED having energy gap around 2 to 3 electron volts, in that case LED will emit visible light. LED will emit visible light. Visible light means the light which we can see with our naked eye. So this is the table from which we can understood the materials which are used to make LED. Also their energy gap values are given in the middle. At the end, finally the amount of light wavelength coming out from LED also we can see. So particularly in the first two cases, silicon and germanium. Silicon and germanium both are indirect band gap semiconductors. They are indirect band gap semiconductors. So if we use silicon and germanium to make LED, in that case most of the energy releases in the form of heat. And gallium arsenide, gallium phosphide, gallium arsenide phosphide, gallium nitride, all these are the direct band gap semiconductors which are used to make LED. When LED is made of these direct band gap semiconductors, there is a possibility of emission of light in the visible region. Particularly when we use gallium phosphide, in that case the color of light that is coming out from LED is green. When we use gallium arsenide phosphide whose energy gap is 1.9 electron volts, in that case red color light will come out. And when you use gallium nitride whose energy gap is 3.4 electron volts, in that case blue color emission takes place. Not only visible light, sometimes invisible light also will come out. Invisible light also comes from out LED. In which case we can observe invisible light when we use gallium arsenide whose energy gap is 1.45. In that case there is a possibility to get invisible light in the infrared region. Particularly in the case of remote TV remotes, we will observe this. Next, circuit diagram is represented here, where we are observing LED, voltage source along with resistor. Here resistor is generally used to regulate voltage and current through voltmeter and ammeter, and a graph is drawn here by taking voltage on x-axis and current on y-axis. Particularly this is the graph through which we can study voltage current characteristics of an LED. From this curve we can say that when V equal to 0, current is 0. When we increase the voltage, current remains constant almost, or it increases very slowly. At a particular voltage current increases all of a sudden. The voltage at which it happens is called knee voltage. The voltage at which it happens is called knee voltage. Knee voltage is different for different colors. So here in the case of red color, knee voltage is 1.8 electron volts. For yellow color, knee voltage is 2 volts, whereas for green color it is 2.2 volts. Now LED materials, so as I told earlier, LEDs are made of direct band gap semiconductors which are obtained by the combination of second, sixth or third, fifth group elements. In this regard, all these are the direct band gap semiconductors: gallium arsenide, gallium phosphide, gallium arsenide phosphide. So finally we can say that based on the material which you are using and the amount of doping will decide the amount of light wavelength that is coming out from LED. Now to operate LED, very small voltage is enough, around 1.5 to 3 volts, and the operating current of LED is 10 to 30 milliamperes, and also the operating power is around 10 milliwatts. And finally, advantages and disadvantages of LED. Coming to the advantages, LED has long life. LED has long life means it will work for many hours when compared with ordinary sources, and it will take less power, means it will consume less power, and also it will operate at low voltages. And LED is capable of emitting different colors from it. That is also one of the advantages. And LEDs are more reliable, and no warm-up time is required in the case of LEDs. No warm-up time means as soon as when we switch on, LED will glow, right? That is, these are the advantages of LEDs. At the same time, LEDs also have some disadvantages. They are more expensive when compared with ordinary light sources. And as I told that LED can operate low voltages. Sometimes when high voltage comes, in that case there is a possibility to damage. And as the time goes on, the intensity of light coming from LED will decrease. As a result of that, this LED will little effective in wide area. And finally, even in the case of LEDs, backward heat dissipation takes place. Now, I am going to conclude this session with the applications of LED. So, LED particularly emits light in the visible region. Visible light emitted from LED has so many applications in numerical displays. In our daily life, we use it to see digital watches, calculators, instrument panels. Instrument panels means in the case of fridge, washing machine, and some other electronic devices, we use it to see where the LEDs and the telephones, switchboards. In all these cases, we will see LED operations. And LED is used in fiber optic communication. In the case of fiber optic communication, fiber optical communication system requires a transmitter, receiver. In the case of transmitter, light source is required to transmit energy in the form of light. In that case, LEDs are used, and they have fast operating speed. LEDs can easily transmit from one state to another state. When we switch on, they will glow immediately. That's why they use it as fast speed switches, and they are used in TV backlighting. They are used in displays, even in many instrument displays, even in physics lab also. In the case of many instruments, LEDs will be there at some corner. When we switch on, LED will glow. Next, they are used in automotives. Almost all automotives will make use of these LEDs, and they are used in dimming of light. So that is how we can find numerous applications of LED in our daily life. And coming to the summary, this is about LED, what we discussed now, which is one of the important optoelectronic device. In the next class, we are going to discuss about one more optoelectronic device, that is photodiode, whose operating principle is exactly opposite to that of LED. Thank you.